This is question 26. The question says a magnet of magnetic moment m vector is 50 I cap ampere meter square is placed in a magnetic field which is a b vector given as 0.2 I cap plus 0.3 j cap Tesla. We have to find out the torque acting on the magnet, and there are four options: 15 k cap Newton meter, 15 k cap plus 10 j cap Newton meter, 10 k cap Newton meter, or the last option which is 0. Dear students, to solve this question, let us first write down the fundamental formula. The torque on a magnet in a magnetic field, dear students, is given as simply m cross b. Now m vector is the magnetic dipole moment, and what is b vector? B vector is the magnetic field. Now in the given question, m vector is given as 50 I cap in SI units, and what is b vector? It is given as 0.2 I cap plus 0.3 j cap in SI units, that is Tesla. Now to find out the cross product, we can use the matrix method: I cap, j cap, k cap. This is 50, 0, 0, 0.2, 0.3 and 0. Dear student, this leads to k cap 50 into 0.3 minus 0.2 into 0, which will be equal to 15 k cap Newton meters. And therefore, dear students, the correct answer for this question is 15 k cap Newton meters, which is the option number 1. Now let us proceed and solve the question number 27. Question 27 says a wire PQ of length 2 meter is made to slide on two parallel conducting rails with constant speed 1 meter per second. The rails are connected together by a resistance of 5 ohms as shown in the figure. So the figure is given in front of us. The power dissipated through the resistor is, and there are four options: 0.6 watt, 0.8 watt, 1.2 watt or 0.3 watt. Dear students, this is a question based on the concept of the motional EMF. We can start by writing down that the EMF induced in the moving rod will be PVL. Now power will be simply the induced EMF square by R. So this will be B square V square L square by R, where R is the resistance. Now dear students, we can substitute the given values. B is given to be equal to 1, so 1 square. V is given as 2, so 2 square. L is 1, so 1 square. And what is resistance? Resistance is 5. This gives us a value of 4 by 5, which is equal to 0.8 watt. And thus we can clearly see that the correct answer for this question is option 2, that is 0.8 watt. Now let us proceed further and solve the question number 28. The question 28 is a theoretical question, and it says that when current is passed through a steel spring, then it first gets compressed, gets expanded, breaks or remains unchanged. Dear students, although this question seems to be from the chapter current electricity, however, it is from the chapter moving charges and magnetism. The key concept here is when there are two parallel current carrying wires, then they attract each other. Now we can use this similar concept in this situation as well. If there is a spring in which a current is flowing, then dear students, each of these links act like a parallel current carrying wire only, and therefore each link attracts each other, and thus the spring gets compressed. And hence for this question, dear students, the correct answer is option 1, that it gets compressed. Now let us move to the question number 29. And this question 29, it says that the particle of charge q and mass m starts moving from origin under action of an electric field E vector is equal to E naught I cap and magnetic field B vector is equal to B naught I cap with velocity V vector is equal to V naught J cap. The time after which its speed becomes 2 V naught is, and there are four options: 2 m V naught by q E naught, 2 B naught q by m V naught, root 3 B naught q by m V naught, and the fourth option which says root 3 m V naught by q E naught. Dear student, the key concept that will help us in solving this question is that the kinetic energy is changed only due to the external work done, and in this case the magnetic field does no work. The work is done only by the electric field. Now in this case the final kinetic energy is half m 2 V naught square, and 2 V naught is the final speed. What is the initial speed? It is V naught, so the initial kinetic energy is half m V naught square. Now dear student, the work done by the electric field will be simply QE0, that is the electric force multiplied by x. Please note that the magnetic field does no work on a moving charge particle as the force is always perpendicular to velocity, leading to no power. Now from this equation we can write down that x will be equal to 3 by 2 mv0 square by QE0. Now dear students, we can use the equation of motion and write down that x should be equal to half at square. Now what will be A? A will be simply force, that is QE0 by mass m, and t square. Now we can substitute the value of x from equation 1 in equation 2 and we can clearly find out that t will be equal to root 3 mv0 by QE0, leading to the option number 4, which is the correct answer. Now let us proceed forward and solve the question number 30. Question 30 says the magnetic flux linked with a coil at any instant t is given by phi is equal to 10t square minus 50t plus 5 Webers. The induced EMF at t is equal to 2 seconds is, and there are 4 options: 10 volt, 19 volt, 5 volt, and dear students, this last option, that is 0. Now in this case, phi is given as 10t square minus 50t plus 5. Dear student, this question is based from the chapter electromagnetic induction, and we must know that the magnitude of the induced EMF can be simply written as the magnitude of the rate of change of magnetic flux, which will be equal to d 10t square minus 50t plus 5 with respect to dt. So this will be 20t minus 50. Now we can substitute the value of t as per the question, and the value of t is 2 seconds. So at t is equal to 2 seconds, E will be simply 20 into 2 minus 50, and this will be, dear students, minus 10 volt. Now as per the magnitude, we can clearly write the magnitude of EMF will be 10 volt, and hence for this question, as per the given options, is option 1, that is 10 volts. Now let us solve the question number 31.